Hello, my name is Aldrich Taruti. Today I will presentation about a palm. Okay, let's begin. Palm definition and palm classification. Definition of a palm. A palm is a type of fluid machine that functions to move fluid through a pipe from one place to another. In carrying out this function, the palm converts the mechanical energy of the shaft that moves the palm blades into kinetic energy and pressure in the fluid. Palm specifications are expressed by the amount of fluid that can be flowed per unit time or capacity and lift energy or head from the palm. Okay, next, palm classification. According to its working principle, palms are classified into two types, namely A. Positive displacement palm. It is a palm that produces an intermittent capacity because the fluid is pressed in the palm elements by a certain volume. When the fluid enters, it is immediately transferred to the exhaust side so that there is no leak. Backflow from the exhaust side to the inlet side. Next, the capacity of this pump is more or less directly proportional of the number of turns or the number of alternating movements in each unit of time from the moving shaft or crank. This type of pump produces a high head with a low capacity. This pump is further divided into 1. Reciprocating pump or piston pump. In this pump, pressure is generated by the alternating translation of the elements with the delivery of the crankshaft, camshaft, and other. Okay, this type of pump is equipped with intake and exhaust valve that regulates the flow of fluid into or out of the workspace. These valves work automatically and the degree of opening depends on the fluid produced. Then resolution pressure is very high, which is more than 10 atm, low rotating speed of 250 to 500 rpm. Therefore, the dimensions are large and very heavy. This pump is widely used in oil factories and the chemical industry for pumping viscous liquid and for pumping boiler water at PLTU. The piston pump scheme is shown in the following figure. Okay, everybody, you can see the figure at our picture. Okay, number 2, rotary pump. The pressure generated from this pump is a result of the rotating motion of the element or the combined motion of rotating. The main part of this type of pump are: 1. Stationary pump housing. 2. Rotor, in which there are rotating elements in the pump housing. The working principle is that the incoming fluid is pressed by elements that move it into the exhaust side and then press it into the pressure pipe. Because it does not have valve, this pump can work in reverse, as a pump or as a motor. This pump runs at high rotation up to 5000 rpm or more. Because of this advance, This pump is widely used for lubricating pump and in hydraulic power transmission include in this type of pump are A. Gear pump. The working principle of this pump is that the rotation of two paired gears located in the pump housing will suck and suppress the pump fluid. The fluid that fills the space between the teeth is pressed against the exhaust side due to the filling of the space between the sides. This pump can operate. The application of this pump is in the lubrication system because this pump produces a high head and low distance. An example of a gear pump is in the image below. Okay, the piston pump. The working principle of this pump is that the rotation of the rotary casing causes the piston to move according to the position of the piston tip on the climb plate. Fluid is drawn into the cylinder and the exhaust flows due to the upward motion of the piston. The function of this pump is to meet the needs of high head and low capacity. The piston pump scheme is shown in the following figure. Okay, the dynamic pump. It is a pump whose working space does not change as long as the pump is running. To change the pressure increase, you do not have to change the volume of the fluid flow in this pump. There is a change in energy from mechanical energy to kinetic energy then into potential energy. This pump has the main element a rotor with an impeller that rotates. High speed included in this type of pump are axial pumps and centrifugal pumps. 1. Axial pump. The working principle of this pump is that rotating the impeller sucks the pump fluid and presses it into the compressed side in the axial direction. This pump is suitable for applications requiring low head and high capacity, such as in the water system. An example of an axial pump is shown in the image below. Number 2. Centrifugal pump. The main element of this pump is a rotor with blades rotating at high speed. The incoming fluid is accelerated by an impeller which increases both its pressure and velocity and throws the fluid out through the valve or cochlea. This pump is used to meet the needs of medium to high head with medium flow capacity. In its application, centrifugal pumps are widely used for the process of filling water in boilers and household pumps. The part of these centrifugal pumps are sucking books, parking shaft, shaft sleeve, fan, casing, eye of impeller, impeller casing wearing, and dirt check nozzle. Okay, I think that is all. Thank you for your attention. Bye.